Hello, my dear students and the rest of the learners. Welcome to this presentation in which we shall be discussing on the topic Introduction to Systems Analysis and Design. This is part one of a two-part series of presentations in this topic. My name is Meme JM, or you can simply call me Emily Swap. In this presentation, I'll look at the definition of concepts in systems analysis and design, the procedure of establishing system requirements, the system design process, and system development or construction process. Let's commence by looking at the definition of concepts of systems analysis and design. When we talk about a system is a set of organized activities, elements, and components which interact in a given environment and within a specified boundary in order to achieve collective goals and objectives that are emergent. For example, an organization may have developed or may need to develop an information system that it uses or it can be using to manage all its activities, elements, and the components. An information system is the arrangement of people, data, processes, information, and other resources that collectively work together to support and improve the day-to-day operations in an organization and the decision-making process. Therefore, when we talk about system analysis, we are referring to the process of helping management to improve an organization by studying and modeling the organization's systems. And for this reason, system analysis is the task that is carried out by a systems analyst, which is a process of collecting and interpreting facts, identifying the problems, and the composition of a system into its components. The systems analyst is therefore responsible for studying or identifying the organization's needs and the problems, and then designing and developing an information system to solve those problems or those needs. And for that reason, system design is the process of detailing how the new system will look like, what it will require, and how it will work. It is the process of planning a new system or replacing the existing one by defining its components or modules in order to satisfy the specific requirements. For that reason, systems analysis and design is the process through which a system analyst studies the existing system within the organization in order to identify its needs and the problems, establish whether those needs and the problems can be solved through automation, and then developing a detailed description of how the new system will look like, what it will require, and how it will work. It focuses on systems, processes, and technology. The following are some of the reasons that can make an organization decide to develop an information system. Number one is to provide the people within an organization with the information that they can use in decision-making process. Number two is supporting information processing by enhancing tasks such as collection, processing, and communication. Number 3 is facilitating interaction and dissemination of information throughout the various levels of the organization. So, it facilitates in sharing information between departments. Number 4 is to provide responsive service to meet the user needs. Number 5 is to store, secure, and manage data within an organization. The three main circumstances or reasons that can make an organization decide to develop an information system include: number 1 is existence of new opportunities. This is a chance to improve quality of internal processes and service delivery in the organization. Number 2 is when there are changes in the organization. The management can introduce new changes, and this happens mostly when an organization undergoes through structural reforms or when new management has taken over. New regulations or directives can also come from the government or other external influences, such as changes in the customer expectations. Number 3 is when there are problems in the current system. Sometimes a new system is developed because of persistent and undesirable circumstances or errors in the current system that, despite of attempts to correct them, has not been successful, and therefore preventing the organization from meeting its goals. However, developing a new system is not usually a one-day event, but it's a process that is supposed to be carried out in a structured manner through a set of predefined stages or activities, whereby systems analysis and design is part of those stages. Developing a new system is therefore a multi-step process through a number of phases, which are popularly known as system development life cycle, that we abbreviate as SDLC. During the active life cycle of a system, analysts may often repeat one or more of the system development life cycle steps in order to make corrections before going too far. The earlier the detection of errors, the easier it is in correcting them and finally producing a reliable product. This cycle is composed of the following main stages or steps that are diagrammatically represented as follows. Number 1, or the first stage, is called problem recognition and definition. The second stage is information gathering. The third stage is requirement specification. The fourth stage is system design, while the fifth stage is called system construction or development. Stage 6 is system implementation and testing, while stage 7 is called the system review and maintenance. And in a case an analyst realizes that a new problem has risen, or there's a main challenge that requires the entire system to be looked at afresh, then we move on to the first step, which is problem recognition definition, and therefore making the process of system development to be called a cycle. Let's now look at the procedure of establishing system requirements. System requirements are clearly articulated statements of what a system must be able to do in order to satisfy the needs and the requirements of the organization. The requirements determination involves understanding the existing system and gathering details in order to find out what are the requirements, how it works, and where improvements needs to be made. The key steps in establishing system requirements are: number one, gathering and developing requirements from the current system. Number two is writing and documenting the requirements. Number three is checking completeness of the requirements, thus defining all the needed system functions. Number four is analyzing, refining, and decomposing requirements in order to ensure that each requirement meets the required characteristic. Number five is verifying and validating the requirements in order to ensure that those requirements are the correct requirements. Number six is managing the requirements. The requirements are presented to the management for approval, and a baseline is established for the way forward. In order for the systems analyst to be able to successfully establish a system's requirements, he or she must undertake the first three stages in system development in their sequence as follows. Number one is problem recognition and definition. Number two is information gathering. And number three is requirements specification, which we also call systems analysis. Let's look at problem recognition and definition. The problem definition, also called problem analysis, is the process of identifying the problem, understanding the problem, finding out if there is a possibility of getting a solution thereafter, and finding out any constraints that may limit the solution. Therefore, the two main questions that an analyst seeks to answer during problem recognition are: number one is whether the project is worth pursuing, and number two is if the project is worth looking at. After this, the systems analyst has to define the scope of the project and establish the constraints, the budget, and the available schedule. Therefore, a feasibility study is a special study that is carried out in order to establish the costs and benefits of a new system. A new system would only be developed if its benefits are more than its costs. The feasibility of a system is assessed in four main ways, which are: number one is operational feasibility. This study establishes the extent to which the users are comfortable or happy with the proposed or new system. Number two is schedule feasibility. This establishes whether the development of the proposed system will be accomplished within the available time. Number three is economic feasibility. This establishes whether developing the new system is cost-effective by analyzing all the costs and benefits of the proposed system. Number four is technical feasibility. This establishes whether the technology that is available is sufficient or can be upgraded for the new system. The six main considerations that must be understood in problem definition and recognition stage for the system development are: number one, whether a new system is required. Number 2 is whether a new system is worth pursuing. Number 3 is the scope of the project. Number 4 is establishing the constraints, budget, and schedule. Number 5 is identifying the problem and understanding that problem. Number 6 is coming up with a relevant proposal for a new system. Let's now look at information gathering phase. This phase is also referred to as fact-finding or system investigation. The purpose of this study is to fully understand the existing system and to identify the basic information requirements. This requires a contribution from the users, both of the existing system and of the proposed system. The 6 main methods that can be used to gather facts concerning the current and the proposed systems are: number 1 is interviewing. Number 2 is use of questionnaires. Number 3 is observation. Number 4 is through record inspection. Number 5 is use of user workshops, while number 6 is automated methods, amongst others. The problem recognition and definition, together with the information gathering phases, form what we call the planning step. They can thus be combined into a single stage that can be called the planning stage. The planning phase entails activities for understanding why a new system should be developed and how the project team will develop the system. Let's now look at system analysis, which is usually stage 3 in system development life cycle. Systems analysis is also called the requirements specification. This is the stage at which the analyst must come up with the detailed requirements for the new system, which include output specification, the input specification, the file and data stores, hardware and software requirements. Analysis involves a detailed study of the current system, leading to specifications of a new system. Analysis is a detailed study of various operations that are performed by a system and their relationships within and outside the system. During analysis, data is collected on the available files, decision points, and transactions handled by the present system. A systems analysis also includes subdividing of a complex process involving the entire system, identification of data stores, and manual processes. The systems analysis stage answers the questions such as who will use the system, what the new system will do, and where it will be used, as well as when it will be used. A requirement is a feature that users identify as being necessary or useful in a system. It is an improvement over the existing system. And during requirements analysis, users and IT personnel explore in detail the various opportunities for improvement and decide the likely design approach at a conceptual level only. The requirements are refined iteratively until and detailed low-level set of requirements are defined and documented. The main steps executed at this stage, which we also call the procedure for analysis, include: number one is development of an analysis strategy. Number two is requirements gathering. And number three is combining the analysis, system concept, and the models to form the system proposal that is then presented to the management. The system specification is therefore the detailed documentation for the new proposed system, whose contents include: number one is detailed specification of all files, screen layouts, and dialog designs, source documents, and output documents. Number two is program specification. Number three is the implementation procedures. Number four is equipment. Number five is user department instructions. The user's requirements are examined further in depth before finally designing the new system. Let's now look at each of the specifications. The first one is output specification. This is considering what is required from the system, because the main interest from a new system is information. So it is necessary to consider what is required from the system before deciding how to set about producing the system. Number two is input specification. It entails identification of the input needed to obtain the relevant information, that is output, from the system. The input to the system is necessary because the contents of the input are used to maintain the master files. Number three is file or data stores. It entails making an informed decision on the files required to store data and information in the system. This includes their number and their attributes. Number four is hardware and software requirements. This is the specification of all the electronic, mechanical, and electromechanical components, as well as the set of programs for the new system. This involves buying the right hardware and software in order to achieve maximum benefits. Number five is processing requirements. These deal with the processing schedules. That is, when the data is input, when output is to be produced, and when files are to be updated, and the identification of logical and computational processing activities. In order to complete the systems analysis stage, you must prepare system requirements document and make a presentation to the management. The systems requirements document contains the requirements of the new system, the information system used for measuring the performance, accuracy, and the completeness of the finished system before entering the system design phase, and should be written in a language that users can understand so that they can offer their input and suggest further improvements. Let's now look at system design process. System design process involves detailing exactly how the expected new system will look like, how it will function, and what it will require in order to make it operational in reference to hardware, software, and the operating procedures. So, the actual details of the necessary specifications, features, and operations that will satisfy the functional requirements of the expected system are formulated. Therefore, system design is the determination of the overall system architecture that will satisfy the system's essential requirements, consisting of the essence of the set of physical processing components, the hardware, software, hardware, and the communication among them. This phase usually designs how the system will operate, its user interface, as well as the software and files that will be needed. The following are the 4 main steps involved that we also call the system design process. Number 1 is determination of the system's design strategy. This is making a clarification on whether it's the organization's programmers that will develop the system, or whether the system will be outsourced, or whether the organization is going to buy an existing system, or what we call a software package. Number 2 is development of the system's basic architecture design, as well as interface design. This describes the hardware, software, and network infrastructure that will be used and how users will move from the system respectively. Number 3 is development of the file and database specifications. These are details defining exactly what data will be stored and where it will be stored. The 4th step is development of the program design. It defines the programs that will have to be coded and what each program will do. The final product or documentation of the design process is a system specification, which is used by programmers to construct or develop the new system. This document is a collection of the architecture design, the interface design, database, and file specifications, as well as the program design. The 2 main objectives of the design phase are, number 1, to design the new system, or number 2, to establish a sound framework of controls within which the new system should operate. Now, the design entails 1, what we call the preliminary design. Preliminary design is a rough draft that describes the functional capabilities of the proposed information system. It's also called the logical design. It is a review of system requirements considering all the major components of the system. In this stage, you consider several alternative systems while evaluating the cost and the benefits of each. The second design is called the detailed design. It is also called a physical design. This design describes how a proposed system will deliver the general capabilities described in the preliminary design. At this stage, or this phase, you consider the input, processing, output, and storage requirements. The completion of the design phase of the system development lifecycle is marked by 3 main events. These are, number 1, the analyst completes, organizes, and assembles the new system design documentation, including records of the general and application controls. This documentation should include, number one, a complete overview of the new system as a whole. Number two is a description, that is narrative or graphics of the major processing modules into which the system has been divided for design purposes. Number three is detailed documentation describing the input, processing, and output activities in each module and submodule. Number four is specification of the storage requirements for the new system and description of each file to be maintained in the system, including anticipated size and organization scheme or access method to be used. Next is a narrative description of the general and application controls to be used within the new system. Now, number two, the system analyst and information processing management meet to review the technical soundness of the design. In other words, the next activity is where the system analyst and information processing management hold a meeting in order to review the technical soundness of the design. And the third step is where the systems analyst, user management, and information processing management meet to present and review the design so as to come up with a decision either to improve the design and proceed to the next phase of the system development lifecycle, or to revise the design before continuing. Some tools that are used for designing an information system and are also used to depict the flow of information in a system include, number one, flowcharts. A system flowchart shows the general flow of information, and it's a tool for analyzing processes that allows one to break down a process into individual events or activities and to display this in a shorthand form showing the sequential or logical relationships between them. The second tool is called the data flow diagrams, or DFDs. A DFD is a program that provides an effective form in which to present or represent movements of data through a system and the associated transactions of the data resulting from various processing actions taken upon it. The third tool is entity relationship diagram, which we abbreviate as ERD. This is a pictorial representation of the information that is created, stored, and used by the organization that also illustrates the relationships between the system entities and their attributes. An entity in this context is anything about the data that can be stored. For example, if a system needs to store data about the customers or products, then the model would have customer or product entities. Number two is attributes. Attributes, or the attributes of an entity, are those facts that need to be stored about that entity. For example, the attributes of a customer might include the account number, his or her name, his or her address, and credit limit. Number three is relationships. These exist between various entities within a system. For example, there may be a relationship between the customer and an owner. They are thus represented by lines between entities. The bounce feet at the end of the arrows are used to show the degree of the relationship. Let's now look at system development, or what we call the construction or coding process. System development is the process of translating or converting the design received from the analyst into an actual system through coding by a programmer using the appropriate programming language, as well as the development of the required hardware and the test plans to be applied. The modules and their components such as outputs, inputs, and the files are developed and tested. So, it is at this stage where the building of the new system begins, following the document that is produced in the system design stage. It is an important stage where the defined procedures are transformed into control specifications by the help of a computer language. This is also called the programming phase, in which the programmer converts the program specifications into computer instructions, which we refer to as programs. The programs coordinate the data movements and control the entire process in a system. The systems analysts, programmers, and the computer operators get together in order to build the new system where each of them has a specific role to play amongst the others. In the system construction stage of system development lifecycle, the system design serves as the blueprint for constructing the new system. Programmers can come at this stage to construct a computerized working model of the same. The Information Systems Department plans, develops, documents, integrates, and tests all the new programs and the code modules. Therefore, at this stage, programmers and analysts assume different responsibilities. An analyst must deliver a clear, accurate set of specifications to the programmer. A programmer then codes, tests, and documents the individual program modules, while the system analyst plans the integration of programs and assures that they work together to meet the business requirements. Coding using one or some of the programming languages such as C++, Java, Visual Basic, amongst others, testing and system implementation take place in this phase. Coding is the process of turning program logic into specific instructions that can be executed by the computer system. There are 3 fundamental steps for designing a program. Number 1 is to define the output and data flows. Number 2 is to develop the logic. Here, you develop the algorithm for the program, either in form of pseudocode or using pictorial representations such as flowcharts, amongst the others. Number 3 is writing the code. At this step, you translate the design into a set of instructions that can be understood and be executed by the computer with the use of a programming language. You can now proceed to listen to part 2 of 2 in this topic. Congratulations for learning part 1 of 2 in Introduction to Systems Analysis and Design topic. You can now access part 2 of 2 in this topic, as well as other computer or ICT videos by clicking or tapping on Emily Swap ICT YouTube channel below this video. You can also visit Emily Swap Life Skills YouTube channel in order to access free life skills, motivational and inspirational resources. To subscribe to this channel, just tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email emilyswap@gmail.com. Thank you very much for listening to me, and God bless.